Intermediate value theorem. This theorem is, let f be a polynomial function. The intermediate value theorem states that if fa and fb have opposite signs, that means if f of a has a negative sign and f of b has a positive sign, or if fa is a positive sign and fb is a negative sign, those are opposites. Then there exists at least one value c between a and b for which fc is equal to 0. So what they're saying is there exists a 0 between a and b if f of a and f of b have different signs. That's what's being said there. And this is for polynomial functions. Now they have to say polynomial functions here because we know polynomial functions are continuous on the whole interval r. So that's necessary for us to have continuity in order to talk about the intermediate value theorem. So the idea is if I have this x and y here, and let's say my f of b is positive, my f of a is positive, sorry, here's my a. F of a is up here, so my f of a would be my y value. So they're saying that y value is positive, and I got a b over here. Oh, hang on, let's keep it on the same side. And I have a b over here, and it's negative. So let's say it's down there. Then what it's saying here, that we know it's continuous, so it's going to have to cross the x-axis. So they're saying, hey, there's going to be a c here at such that f of c equals 0. So there's going to be a c between a and b where it has to be 0 because it's going to hit the x-axis, which means it's a 0 for the polynomial, which also means it's an x-intercept if I think about it graphically. So that's the big idea here. So since they give us an interval for the problem below, this says use the intermediate value theorem to show that each polynomial function has a 0 in the given interval. So here's our interval here. It's between -4 and -5. So what we're going to do is we're just going to plug in -5. And if I plug in -5 into that function there, I'm going to get -58. And I'm also going to plug in -4. And if I plug in -4, I'm going to get 2. Now notice here the signs are different. They're opposite signs. So that tells us then that there exists at least one c So we would say because I would have to say first that f of x is a polynomial, and that would just state continuous. That's the condition I'm looking for in that polynomial. And we know they're all continuous. So because f of x is a polynomial and f of -5 equals -58, or I don't have to say that, f of 5 and f of -4 have opposite signs, then by the intermediate value theorem, IVT, there is at least one value between and I won't say between, I'll say in the interval. That's the interval, -4, -5, -4. So there's at least one value in -4, -5 that is a 0. So there's the answer for this one. That's really it. All I have to do is make sure it's a polynomial function for this example here, and then take the f of the two endpoints, or end values, and then if they have opposite signs, I can simply say there is at least one value in the interval that is a 0 by the intermediate value theorem. And I have to state by the intermediate value theorem. If I don't, it's not correct.